All right, so we're gonna work on this page in your workbook. This is the modeling page that you're gonna put your responses to these questions based off the model that we did in the classroom. So what I want you to do right now is in the drawing of a normal red blood cell section of the page, go ahead and using the function of Word, or if it's printed out for you, or if you can't, just create, draw, or put any picture from the internet of a normal red blood cell and what it looks like. So this is what I got. Here's my drawing of a normal red blood cell. A normal red blood cell is circular. I added this feature of a red blood cell. It's a little like shaded section of the middle to show the indentation of a red blood cell. The reason why there's an indent, well, that info is to come later. So if you don't have that feature of your red blood cell, I highly suggest you go ahead and add that to your drawing. All right, so the next part is actually modeling the normal red blood cell. So I have my green clay here, and I'm just going to make roughly like 7 red blood cells. It's a little bit big. So the class made about 7 of these. They made them nice and round. So there's one. Some kids, they get really into it, and they like to maybe use their eraser or the tip of their pencil, and then they tend to make like the little indent to represent. Can you see that? The little indent that is in the center of our red blood cell, but not needed. All right, I probably will speed this up, but I'm gonna make like 5 more of these. All right, so here are my 5 normal red blood cells made out of clay. So the next thing I'm going to do is that this is just some cornstarch. We're just going to throw our 5 normal red blood cells into some cornstarch. The reason why we did this in class is to make them not so, I guess, sticky per se, because clay is naturally sticky. And so we are just going to coat them a little bit of cornstarch. So yeah, that's fun. All right, next I have my little Erlenmeyer flask, super tiny. If I have my pencil, you can kind of compare to like how tiny it is. This flask represents a blood vessel. So again, this Erlenmeyer flask represents a blood vessel. What I'm going to do is that our little red blood cells belong in our blood vessel. So I'm gonna throw those in there. Okay. So the next thing that we did as a class is that we take this Erlenmeyer flask, our blood vessel that has our red blood cells in it, and we are going to invert it upside down, meaning we're going to tip it upside down. I'm not going to do it yet because we have a prediction to make. So the question I'm going to ask you is, what do you think is going to happen once I invert this upside down? What do you think is going to happen to these 5 red blood cells once the flask blood vessel is tipped upside down? You are going to write your response in the second box where it goes prediction of what you think will happen. If, then, because. So if Miss M tips the blood vessel upside down, then what do you think will happen? And because. So what's your because? So why do you think the way you think will happen once I invert this blood vessel upside down? Pause the video and write your prediction. Hi, all right, different angle. So we are gonna do the next part where you are going to draw what happened. So different view, because I want you to get the front view, so you can see what's going to happen once I invert the blood vessel. So remember, we have an Erlenmeyer flask, which represents the blood vessel, and we have our 5 red blood cells. So I'm going to invert it in 3, 2, 1. What happened? All right, so you're going to draw what happened. What happened? Use arrows and labels. So you should have like a before and an after using arrows to show movement. What do you think happened? Pause the video so you have time to draw what happened. All right, next step of our normal red blood cell side is explain what happened. So you drew what happened. Now use your words to explain what happened. Make sure you use complete sentences. All right, now we are on the sickle cell red blood cell side. So it's just the same as the normal red blood cell side. Go ahead and draw what a sickle red blood cell will look like. Go ahead and draw it. Pause the video. All right, here's what we got. So this, like a picture of a moon or a banana, is a typical illustration of a sickled red blood cell. But this is also a great illustration of a sickled red blood cell, and so is this one right here. What makes some very good drawings of sickled red blood cell is that they are not a perfect circle. So anything that's not a perfect circle is going to be a sickle red blood cell. So if this little nice round circle, that's a good representation of a sickle red blood cell. If I were to use a post-it note to represent a sickled red blood cell, I'll be like, yeah, this will be a sickle red blood cell because it's not a perfect circle. All right, next, we're gonna be working on the prediction. All right, so I have my blue clay. Remember that I used the green clay to represent the normal red blood cell. I'm gonna take a little bit of this clay and model a sickle red blood cell. Remember, a sickle red blood cell is anything other than a perfect circle. So like, I don't know, do you see the teardrop? That'll be one. Let me make one that's kind of traditional. Sorry for the sniffles. There's one that's kind of crescent like a moon. And again, the kids in class just made anything that was other than a perfect circle. So like, this one's interesting. There's three. I'm gonna make like two more. Probably fast forward. Here are my 5 sickled red blood cells. They are very random shapes. What makes them sickled is that they're anything other than a perfect circle. So I'm gonna take my cornstarch just so that they are not so sticky, because clay has a sticky aspect to them. Just slightly coat them. This is the messy part of the activity. There we go. And next, we have our famous Erlenmeyer flask, which represents our blood vessel. I'm gonna take our sickled red blood cells, throw them in our blood vessel, and then we're gonna make some prediction. So remember, I'm going to invert this, turn it upside down. What's going to happen? So we are right here. Prediction of what you think will happen. So if I were to take my Erlenmeyer flask, my blood vessel filled with my sickled red blood cells, invert it, turn it upside down, what do you think will happen? Make sure you use the if, then, and because format. If Miss M does this, which is if Miss M inverts the blood vessel, then I believe this will happen. Because why do you think so? Pause the video so you can write your prediction. Hi guys, okay, here's our blood vessel, our Erlenmeyer flask. We have our sickled red blood cells in there. I'm going to invert it upside down, and we are going to see what happens to our sickled red blood cells. In 3, 2, 1. So if you notice, some came out, but look, can you see? Let's do this. Some got stuck. All right, next part. All right, you know the drill. Draw what happened to the sickled red blood cell. Remember, some came out, some got stuck. Do a little before, a little after, use arrows to show movement, and don't forget to label everything. And lastly, now that we drew what happened, explain what happened using complete sentences. All right, here's a different view. Here's our blood vessel, our Elmira flask that has our sickled red blood cell. I'm going to invert it in 3, 2, 1. Oh no, that wasn't supposed to happen. All right, so here is our Elmira flask. Represents our blood vessel. I have our sickle red blood cells in there. I'm going to invert, turn upside down the blood vessel, and let's see what happens. In 3, 2, 1. Oh my God. Why is it? All right, guys, so here's our blood vessel with our sickled red blood cells in there. I'm going to invert it, turn the blood vessel upside down, and let's see what happens. In 3, 2, 1. Why does it not work?